And we are back. In the last video, we started setting up our log manager. We have it here, log manager. And then in this video, we're going to keep setting up our console service. Our console service is literally just a log service that is going to print to the console. Let's go ahead and start just separating out these files. So just like we did with all of these other, all of our other managers, we created a services folder. Within logs, let's create a new folder called services. And let's cut our console service. And I will paste it in the services folder. And I'll also take the log service and I'll paste that in the services folder. We have this loggable event, which I will also just cut. And for now, let's also just put that in the log service file. We'll move that in a little bit. Maybe I'll import SwiftUI here. So Command R to make sure that we are still compiling. All right. So I'm jumping back into our console service now. And right now we are just printing to the console, but Apple actually released a framework called OSLog. So we could import OSLog. And there's actually a logging system that is baked into Xcode now. I will put a link below for an article about how you guys can learn about it. A lot of you guys have probably already seen this blog, Swift Leads, one of the most popular Swift blogs. If you are not subscribed, I would highly recommend joining this email list. He has some really great content. It comes out, I guess, every Tuesday. But this article will just run you through about what OSLog is and how to use it. And it's basically just an alternative to print statements. We can just access a logger and then log rather than print. So read through that article, but without further ado, I'm going to get going here and we're going to create our own logger now using the OSLog framework. So I don't think that the OSLog needs to be on the main thread. So let's go ahead and make it an actor and we'll call this the log system. And in here, we need to get access to the logger inside OSLog. So here I'll say let logger, set it equal to a logger. And there is a subsystem and a category. Now, a subsystem, we're just going to use the bundle.main.bundle identifier as the subsystem name. And the category, let's just put console logger. I don't think it really matters what we put here. My understanding, this is primarily in case we have multiple loggers in our code base. We can name them differently. The article I'll link below does explain this in more detail. But we're only going to have one in our whole code base, so I'm fine with just calling it console logger. Now in here, we're going to create a function called log. And then we'll call logger.log. And when you go to log to the logger, there's multiple OS types here. We can press the period and we can see it's actually an enum. There's debug, info, default, error, and fault. And these will actually print out slightly different in the console. So when we go and log something to the log system, we should pass in a level of type OSLog type. And then we'll pass in the level here. And we're also going to pass in a message. Now this message says OSLog message, but we're just going to pass in a message of type string. And then we'll just convert it to a string just like that. When we initialize a console service, let's create a log system. We'll say let logger equals log system. We'll make the logger in here private. So in my console service, I should now be able to call, let's call logger.log. And then we can pass in a type. Let's just do debug and then our string. The logger is in a actor, so we should actually task await and switch into the logger. I don't want to have to make this task every time, so we're just going to get a little hacky here, and we're going to create another function inside the logger that's called log. But this one will make non-isolated. So this function, even though the syntax is within the actor, this function is not actually running in the actor. So from this log, which we can now call from any thread, we'll create a task and we'll await the other log with the level. So now we'll be able to call this one from our code. So we'll be able to call logger.log from down here. Now, when we pass in the action here, we're going to pass in a OSLog type. And we've had a bunch of situations in our code base already where we have some type that is specific to a dependency, a type that is specific to Swift data, a type that is specific to Firebase. Here we have a type that is specific to OSLog. So I don't want to now pass this OSLog type around my entire code base, because as we know, then we're going to have to import OSLog around the whole code base. So let's create our own local version of OSLog type. So let's create an enum, and let's just call it log type. And I have 4 different log types. We'll say case info, case analytic, case warning, and case severe. And so every time we trigger any sort of log in our code base, we're going to decide for it to be one of these 4 cases. Let's add a little description for what each of these are going to be used for. So info, we're just going to use info for informative tasks, such as for informative tasks. And we'll say these are not considered analytics, issues, or errors. So for info would be things that I basically want to like print out to the console, but it's only for me to see when the console runs. And I don't actually want to send the analytic to my analytic services. Analytic will be the default type for analytics. Warning is going to be issues or errors that should not occur, but will not negatively affect the user experience. So if there's something fails in the code base, but it's okay. So for example, we had some like loading things where maybe sometimes it's not supposed to load and that's okay. We'll log that as a warning, versus a severe is going to be issues or errors that do negatively affect user experience. So severe would be something like a screen doesn't load and it's totally broken. So severe is for like the worst case scenario things in our project. So when we go ahead and we call log, let's pass in a log type instead of an OSLog type. We'll pass in a level of type log type. And now we want to convert our log type to an OSLog type. So in our log type, we'll create a variable called OSLog type that is of type OSLog type. And let's switch on cell. And so if it is the info, let's return the OSLog type of .info. If it is an analytic, let's return the default. If it is a warning, let's return the fault. And if it is severe, let's return the error. So now I should be able to call level.OSLog type. And then here, maybe we should capitalize this because OS is a specific framework. And then here, we'll pass in the message of type string. And I'll pass in the message here. So now from my code base, I should be able to call logger.log. And we'll look for the synchronous one. Notice how this one is async. This one we can now call without creating a task. And we'll just pass in analytic, and our message will be the string. Go ahead and delete this. When we go and build and run, we should see that this actually works. So I think we do call identify user in our code base already. What I'm going to do for this one build, let's just copy and paste this a couple times. 4 times. Let's switch these. So we have, let's just do one for each of our cases. So case info. I think we need to clarify the compiler is getting confused here. This should be the log type.info. This one we'll call let's do analytic, warning, and severe. Analytic, warning, and severe. I'm just going to build and run our app real quick. So hopefully the identify user now will print out with 4 different times using our console logger. So we can see here it printed out 4 times. So the info is going to look like this, the analytic, the warning, and the severe. And I think I messed it up. I actually want the severe to be the red one and the warning to be yellow. So let's go ahead and switch our warning to be error and our severe to be a fault. Build and run it one more time, and I think that is what I meant to do the first time. Cool, so now I can see in the console, immediately I'll know if something is yellow or red, there is a problem in the code base, especially if it is red, that means I probably want to address it immediately. Now I do see here that the first 2 look the exact same, and I can't really tell which is which. So a lot of log systems actually put little emojis in the actual string. And so we're going to do that quick. It's a fun touch, and it's also just super common in a lot of loggers. So within the log type, let's go ahead and create another variable called emoji. of type string. Let's switch on self. And then for the info, the emoji will be Control Command Spacebar. Let's do maybe the wave. So just a little hello from one developer to another. Let's paste this a couple times. And then for the analytic, let's go ahead and change this to, I'll use the chart here. For the warning, I'm going to use the warning, this yellow warning. And then for severe, let's go ahead and use the alert. And so now when we start triggering events, we want to actually we're going to actually prefix the event with the printout with the emoji title. All right, but before we get to that, let's just copy the string here for the analytic. I just want to paste it into the identify user manually. Let's just put it here. I'll put one down here as well for log user properties, as well as delete user profile. I'm going to keep my identify user as the info, and I'll delete these other ones. Let's go ahead and copy this and make our add user properties also an info. I'll make our delete user profile info as well. And lastly, in our track event, this is the main one that we're going to call a whole bunch of times throughout our code base. So we're going to be tracking a bunch of different events. And when we actually trigger the event on the screen, at that time, I want to determine which log level it should be. So on the screen, when I write the code, I want to say it's going to be an info or an analytic. So we're going to go and jump into the loggable event. And in addition to providing a name and parameters, let's also make sure that it provides a type of type log type. We'll make this get only. So now when I do have this track event, I can now take my logger method, and here I will call events.type. So we'll pass in the different type depending on what we triggered it as, and then we'll pass in the message. Lastly, where we have our event name, let's also print out the emoji with a space and then the event name. So we'll put up here the events.type.emoji. And then we'll put a space and then the event name. Let's test this out now. So I'm going to jump back to where we have our fake analytics. I think it's in the app view. And let's create some fake events here. Let's create an enum called maybe event. And we'll make sure that event conforms to loggable event. Let's go ahead and conform to it. All right, so every event for the app view is going to have event name, parameter, and a type. And let's just, for now, we'll just do case. Let's just name our events alpha, beta, gamma, and delta. And then for the event name, let's switch on self. And here I'll return, let's just do event alpha. And I'll just copy and paste that a couple times just to show you guys what we're going to do, because we're going to do this in a bunch of videos coming up. Alpha, beta, gamma, and delta. For the parameters, let's go switch on self. For alpha, let's return a fake dictionary that just says AAA, maybe true. Let's also return maybe BBB. We'll put some numbers in here. And I'll actually return that for both alpha and beta. And then for the other two, I will just default here to return nil, because this is optional, so we can make it nil. Lastly, for the log type, let's switch on self. For alpha, let's return the info. For beta, let's return the analytic. For gamma, let's return the warning. And delta, let's return the severe. We need to actually return the dictionary here. All right, so now we have a loggable event. And so in our screen, we should be able to call log manager dot track, and we can track an event. So we'll call the event.alpha, and let's copy and paste this beta, gamma, and delta. Let's build and run it to a simulator. If all works, we should see now these 4 different events come out to the console. Cool. So we got our identify user, we got our log user properties, and now we have our 4 events here. So now I can see in real time, even literally just by the emojis, I can see the info ones, the analytic ones, the warnings, and the severe. and the two that have event parameters, so those parameters printed out below it, which is exactly what we expected. So now when I start moving through my code base, I can very easily start deciding, what do I want to print out? What do I want to log? What is actually an error? And if while I'm developing, I start getting a bunch of red errors, I know immediately that there's something broken in the code base. The last thing I want to do in this video is actually, let's create a toggle for these parameters so that we can turn them off. As you can see here, already, we don't even have that many analytics, and this is already taking up a lot of screen space. And you can imagine that most of the time, the parameters that we send in an event are not really that important to us as the developer. Like occasionally I do want to debug the actual values, but most of the time this is just going to clog up the console. So just like we did with all of our mocks where we added a config where we could inject a value for like custom users, custom mock users, let's inject a value into our console service. Let's go to our console service and let's go ahead and create an initializer. Create a custom init here. And we'll just say print parameters. Make it of type bool, and we'll set it equal to true by default. So normally we will print the parameters. Then we'll say private let print parameters of type bool, and we'll set self.printParameters equals to print parameters. Now just back in our code, let's go ahead and customize these methods here. And then so down here, add user properties, I will go ahead here and I'll say, let's only append to it. We'll say if print parameters, then we do all of this. And then for track event, if print parameters and this, then do this. Cool. And I'll just keep these printing out all the time so that I always get the user ID, because the user ID is pretty important and I want that almost always. So console service, now we can inject print parameters. Let's test it out. Let's go back to our dependencies. And right now we are running the mock scheme to the simulator. So in our mock scheme, we have a print parameters, and right now it's set to true. Let's go ahead and set it to false. And hopefully now the parameters will actually not trigger anymore, and our console will look a little bit cleaner. There we go. Cool. And that, my friends, is how you build a logger. There are many loggers out there. If you go on GitHub and you check out Swift Logger, there's a whole bunch. One of the most fun parts of a logger is adding in the analytics. I've seen people do crazy analytics and like really custom to like get some kind of theme going in their own custom logger. These, what we did here, I think are just pretty generic and pretty self-explanatory, but this is definitely going to help us as we start loading up our code base with lots of logs and analytics in the next couple videos. Eventually, we're actually going to even refactor all these print statements so that these will also look like official logs that come through our logger. And the two cool parts now that we have is the ability to toggle on and off print parameters. But we also, if we don't include our log service and we ever build and run it, now we don't get any of those things to print out to the console. So these will also be deleted once we move them into the console logger. So now very easily, we can literally turn on or turn off printing for the entire code base. That's all for this video. Let's go ahead and Option Command C. Let's make this a feature, and we will call this the OSLogger. Let's stage it. Let's commit it, push it on up to GitHub, and I'll see y'all in the next video.